For a three-phase circuit, the voltage drop formula is voltage drop equals 1.732 times I sub L times L times power factor divided by E times N sub L, where voltage drop is the voltage drop in volts, I sub L is the current draw in amps, L is the length of the conductor in feet, power factor is the power factor, E is the phase-to-phase voltage in volts, and N sub L is the number of conductors carrying current. In this case, power factor equals 1 assuming the lights are operating at a unity power factor, E equals 208 volts, and N sub L equals 2 since only two phases are being used. Each light at the third pole draws 5.2 amps. Therefore, the total current draw between pole 2 and 3 is I sub L equals 2 times 5.2 amps equals 10.4 amps. The distance between pole 2 and 3 is 200 feet. Using the three-phase formula and the above values, we get voltage drop equals 1.732 times 10.4 amps times 200 feet times 1 divided by 208 volts times 2 equals 2.23 volts. The voltage drop between the building and pole 1 is the voltage drop between pole 2 and 3 plus the voltage drop between pole 1 and 2. Since the lights between pole 1 and 2 are connected across all three phases, we can use the three-phase formula again. The current draw between pole 1 and 2 is I sub L equals 17.9 amps minus 10.4 amps equals 7.5 amps. The distance between pole 1 and 2 is 110 feet. Using the three-phase formula and the above values, we get voltage drop equals 1.732 times 7.5 amps times 110 feet times 1 divided by 208 volts times 3 equals 1.33 volts. Adding the voltage drop between pole 2 and 3, which is 2.23 volts, and the voltage drop between pole 1 and 2, which is 1.33 volts, we get a total voltage drop equals 2.23 volts plus 1.33 volts equals 3.56 volts. The percentage voltage drop is voltage drop percentage equals voltage drop divided by E times 100% equals 3.56 volts divided by 208 volts times 100% equals 1.71%. The calculated percentage voltage drop of 1.71% is less than the 3% allowed by code. Therefore, using a number 6 conductor for this application is acceptable. As an alternative, you could use table 8 to determine the voltage drop. For a number 6 conductor with a current draw of 5.2 amps per phase, the resistance per 1000 feet is 0.393 ohms. Therefore, the voltage drop over 200 feet is voltage drop equals I sub L times R times L equals 5.2 amps times 0.393 ohms times 200 feet equals 0.41 volts. The total voltage drop for the circuit is then voltage drop equals 2 times 0.41 volts plus 1.33 volts equals 1.75 volts. The percentage voltage drop is voltage drop percentage equals voltage drop divided by E times 100% equals 1.75 volts divided by 208 volts times 100% equals 0.84%. This method also confirms that the voltage drop is within the allowable limit.